Bismillah ar-Rahman ar-Rahim. This video is part of the Upsolving for the first data structure contest from the ICPC IIUM 2020-2021 training. In this video, I'm gonna explain problem K. I will leave the problem link and the contest link in the video description. So now opening problem K, and that's originally from Code Forces. You can pause the video or like go to the problem, pause the video, try to read the statement and just understand what the problem asks us to do, and then you can come back to the video. We will discuss how to solve the problem. Also try to spend like some time coming up with the solution yourself. If you fail, then try to watch the video. Do not just watch the solution without spending enough time thinking about how to solve it. Okay, so I'm assuming now you read the statement, you understand what the problem asks, what the problem statement is all about. Briefly, the problem gives as an input n rings. You can think of this as like ring or some shape, circular shape, some cylindrical shape. Every object has an inner radius, an outer radius, and a height. And then we need to stack some of them on top of each other, such that we can get the maximum height of a tower that can be obtained. But there is some conditions to place one ring or one object on top of the other one. The first condition is if you're gonna place ring or object A on top of object B, the outer radius of the higher or the ring on the top should be smaller than or equal to the outer radius of the one below. So Bj has to be smaller than or equal to Bi in order for you to place ring or object J on top of I. And one more condition, which is the outer radius of the object on the top should be greater than the inner radius of the one on the bottom. And this actually makes sense so that the object will not like fall within. If we look at this picture, so this is how the structure look like. We have this shape of some inner radius and then some outer radius, and this is the height. To place another ring, another object like this on top of this object, it has to have an outer radius, like the B of the next object or the new one on the top, should be less than or equal to this B, so that it will not be outside. That's the condition. The other one is the outer radius of the new object should be greater than A. It should not fall within. If it's like A or smaller than A, it will just fall in this hole. We need to stack them one on top of the other one, like to construct a tower. So the outer radius should fall in this area, greater than A but smaller than or equal to B. Okay, and the problem give this set of rings, and then asks what is the maximum height of the tower that can be obtained. So first observation we can think of is if two rings have the exact same outer height, if two rings have the exact same B, the exact same outer height, we can kind of merge them into just one ring. If I have two with the exact same B, so that we can make the calculation easier, we will just assume that we will merge all rings with the same outer radius, with the same B, into one. So if I have two rings with the same B, with the same outer radius, we will merge them into one ring, a newer ring with the same outer radius. The height of the first one plus the height of the second one is the new height, but the inner radius will be the smallest between them. So if I have one with this radius, one with some smaller radius, I will take the one with the smallest radius. Why? Because this makes sense. I can place the one with the biggest radius first, and then the one with the smallest radius on top. So what I care about when I'm trying to stack any more rings is the inner radius of the higher one, which is the smaller one, and this will give me more more chances to add other rings. Let's say one of them has inner radius 5, one of them has inner radius 3. So if I have an object with inner radius 4, it cannot be placed on top of the ring with inner radius 5, but it can be placed with the inner radius 3. So when I'm merging two rings with the same outer radius, I will take the minimum between the inner radius, the same outer radius, and I will sum up the height of them. And then now I have set of rings with all of them have unique value of the outer radius. How can we get the maximum? How can we get the maximum total height of a tower that we can obtain? If we sort all the rings with the outer height, so for example, in this case, I have one with outer height 5, and then 6, and then 7. At every point, you can only stack rings like in one direction of the array. So if you iterate the rings one after another, at every point you will only worry like the next ring that I can take, that I can consider, is from this direction, that like from the rings that I haven't considered yet. So we can formulate some kind of dynamic programming that have a formula of the form. Let's like get something to type in. We can have a dynamic programming that represent the maximum height ending in ring I. So from the beginning until ring I, what is the maximum height I can achieve? Okay, that ring I is the one on the top. Okay, so sorting all the rings in non-increasing order, or in this case, since all of them are unique, in decreasing order. So I first have ring of outer radius 7, and then ring of outer radius 6, and then 5. I will start stacking them, and at every step, if I'm like right now stopping at this ring, what is the maximum height that this ring can be the ring on the top? Okay, and at the end, the highest the highest value of this dynamic programming will be the answer. So how can we calculate this dynamic programming? So dp of I will be the maximum value of db and j of like previous value calculated, such that the, let's say, I outer will be greater than j inner. Okay, so I can only stack, and like I have this value for all j from, let's say, 1 to I minus 1. So I can only stack a ring. If the outer height of this ring is greater than the inner height of the previous ring. I already like sort all the rings, so for sure that the outer ring of I is smaller than the outer ring of j, since we sort all of them. So now I can only, or like I should only care about the relation between the outer ring of the outer radius of the new ring, like with respect to the inner radius of the previous ring, the one I'm gonna stack on top. So this will be the maximum, this will be the answer for db of I. So db of I will be the maximum db of j, such that, or the condition is, the outer radius of I is greater than the inner radius of j. Okay, and of course it will be like I height plus this value. So that's the value that we need to consider. So solving this dynamic programming like in a naive way, it will result in like O(n) square solution, which is not enough to solve the problem with this constraint. So we need to come up with something faster. We can implement some form of like RMQ segment tree to solve this problem. That will make the complexity n log n, but instead, like we can have an RMQ over these values, which will be just not, instead of linear time, it will be logarithmic, and it will solve the problem. But we can actually achieve something even better, like better complexity, with like simpler code without implementing any advanced data structure or any segment tree. And that is between all the values, between all the previous rings that ring I can be stacked on top, I only care about the first one. And by the first one, I mean the closest one to you, like to I. So if I have, like, let's say R1, R2, R3, R4, R5, so this is like some rings. And then ring 4 is like now I at ring 4, I need to check between ring 3, ring 2, and ring 1 to calculate this dB. And let's say ring 3 is not valid, like I cannot stack 4 on top of 2, but I can stack ring 4 on top of ring 1 and ring 3. So in the straightforward way to solve this dynamic programming, you will check every one of them. But there is another observation, which is you only need to consider ring 3 but not ring 1. Why? Because if ring 4 can be placed on top of ring 3 and ring 1, then ring 3 can be stacked on top of ring 1, which means only considering ring 3 is enough, because if you consider ring 4 on top of ring 1, this is not optimal answer, because you can place ring 3 in between. So if ring 4 can be placed on top of ring 3 and ring 1, this implies that ring 3 can be placed, it has to be valid to place ring 3 on top of ring 1. Why this is the case? Like why this is true? The answer to this is simple. Now, after we sort all the outer height, I can assure that for every ring, the outer height of any of these rings is smaller than the previous ring. Okay, so for ring 4 to be placed on top of ring 3 and ring 1, it will only consider, or the condition will be that the outer radius of ring 4 should be greater than okay, so let's say R4 outer, this should be greater than R3 inner, and R4 outer is greater than R1 inner. Okay, so R4 outer is like, for the condition to be true, if R4 can be placed on top of 3 and 1. I'm implying, or I'm assuming that if this is the case, then R3 can be placed on top of R1. So the condition for this to be true is R3 outer should be greater than R1 inner. Okay, if R4 outer is greater than R1 inner, and R4 outer is already smaller than R3 outer, because we already sorted by the outer ring. So the biggest outer ring is R1, and then R2, and then R3. So the outer ring of 4 is smaller than 3. So this, of course, if this condition is true and R4 outer is smaller than R3 outer, then of course the bigger outer ring will still be bigger than the R1 inner. Okay, again, if R4 can be placed on top of R3 and R1, I'm only interested in R3. Why? Because this implies that R3 should be stacked, or it has to be valid to stack it on top of R1. So for every ring, I'm only interested in the first element to the left, which I can be stacked on, and that's the only value we will care about, we will consider. And how can we get this? We can use, like, we can get these values using stack, a simple iteration, and keep the values in a stack and keep popping the values from the stack as long as it's not valid until we reach the first element that is valid. It was the exact same idea we used to solve problem H and problem C, if I'm not mistaken. Yeah, this problem and this problem from the last video, using the stack. So that's what we're gonna do. Again, initially we will merge all the rings that had the same outer height. We now have unique outer heights. We will sort all the outer heights from the biggest to the smallest, and then for every value we will calculate this dynamic programming, or this answer, which is the answer or the maximum height for some element, like ending at this element, will be the height of this ring plus the maximum answer from all the previous rings, like such that I can be placed on top of that ring. What is the condition to be placed on top of that ring? My outer radius should be greater than the inner radius of the previous ring. Okay, and this Dynamic programming can be calculated, and instead of checking all the previous element, I'm only interested in the first one of them. Okay, so we can move now to implement this idea. So first, let's get the input n, and then three values: inner ring, inner radius, outer radius, and height. So n, and then we have three values. So pair of end and end and another end. Let's call array, and 1, 2, 3, 4, 5. That's n. Since we are like considering the outer ring in this calculation like more often, I feel like it make more sense to like have this before that. I just feel this is confusing, inner, outer, and then height. Like for me, it make more sense to be outer, in, and then height, but it's exactly the same. So I'm just gonna read the input in this manner. Array of I, first, second, which is the inner, and then outer ring, outer radius, and then the height. Okay. Now let's merge all of the elements with the same outer. So now, since this structure have the outer radius in the beginning, we can simply just run sort, and it will sort them with the outer. And since we are interested in the sorting decreasing order, we can just reverse this sort. Pair, end, and end. Yeah, this is true. Yeah, this should be fine. Okay, and then iterate, but we will merge them, so we can use another structure, another list, pair of end and another end of v. So for I, we need, like right now, for every element, let's merge all the rings with the same outer radius. So we can just take a copy. Let's say O2 current equal array of I, and then while I is less I plus 1 is less than n, and at the same time the array of I plus 1 outer radius, which is first, is exactly the same as this current element of first. We will merge both of them. How to merge both of them? We said the outer radius will be the same, the inner radius will be minimized, like we will take the minimum between both of them, and the height will be accumulated. So the current dot second, which is the height, plus equal array of I plus 1 dot second, and the outer radius is the same, but then inner radius will be the minimum between the inner radius and the inner radius of the next element, so first and second. And let's just increment I. Okay, so now this vector v contain all the rings merged, where not all the rings, like all the equal outer radius rings merged together, and it's already sorted in decreasing order. So now we can define another vector, but this will contain the answer, which can be really huge. So let's make it long answer of size v, and then size of v plus, and then plus I. We also need the stack, so stack of n st. For every element, we will keep removing the element from the stack that's not an answer, and once I hit one which is an answer, I will keep it, and that's my first that's the first ring to my left, or like previous ring I can be stacked on. So while the stack is not empty, so not st empty, at the same time the array of, not array, it should be v of st top. The again, so this is the previous. I should compare the inner radius. So inner is first, second is greater than or equal to v of I dot first, which is my outer radius, as long as the inner radius is greater than or equal to the outer radius of the current element, we will pop this from the stack. Once this loop terminate, if the stack is empty, there is no previous ring, so the answer that my current ring will be the top, will be just this ring, so answer of I will be v of I second, which is the height of the current ring. Otherwise, the answer of I will be same height plus answer of st top. Okay, and then push the current element to the stack, and then now we should have the answer. We can just calculate it on the way. So long, let's say result equals 0, and at this one we can say the result equal the maximum between the current result and answer of I, and then that's it. Now we should have the correct answer. Let's compile this and add. There is an issue greater. Yeah, I did not close the bracket for greater, so 37. Okay, and then in here we need to have another one like that. That should be fine. Now put the input. The answer is 0, and that's not intended. So what did we miss? Now this is the answer, and then the stack. Why iterate over every element? Okay, let's first check if the size of v is actually correct. In the first test case, it should be 3. It is 0, so the merge itself. Let's also check the case is correct. So then we have an issue in the merging itself. Yes, this is the issue. We did not push this to the vector current. Like we did the merge in this current temp value, but then we did not add it to the v. So now add it to the v, compile, no errors. The answer is 6, which is correct. Let's try the second one, and that's 4, also correct. Okay, let me submit in here. Copy this file. Okay. Okay, that seems promising. Just 33. And Happy New Year. So this was the solution to problem K, Hanoi factory. If you have any question, feel free to ask in the group if you are part of the training, or just in the comments. I will try to get back to you as soon as possible. That was it for this problem. Thank you so much.